Now it tells us that the point A has coordinate 5, -4, and point B has coordinates 13 and 1. And just quick recap, guys, yeah? The coordinates are always in the form x and y, where the first position is x and the second position is y. Now in part A, they want us to work out the coordinates of the midpoint of AB. In other words, the halfway value of these 2 points, yeah? Now there's a nice and easy way to calculate the halfway value of the midpoint M, yeah? What I would do is just look at the x coordinates for a second, 5 and 13. I would add them up. So 5 plus 13 gives us 18. And then I would half the value. And then I'll do the same for the next one. We'll do -4, add 1, which is -3. And then I'll half that as well. And then when you put this in the calculator or just do it mentally, you'll get 9 and -1.5. And that's it. That's 1A done. Okay, now moving on to parts B and C. Well, it tells us that we have a line L that has equation y equals 2 minus 3x. Okay, so this is a straight line equation. Guys, when you have straight line equations, always think of this. Y equals mx plus c, where m here is your gradient and c is the y-intercept, yeah? So in this question, they want us to work out the gradient of the line L. Well, just look at this equation here right now. I would just tidy this up a bit. I'll make it look like this form right here. So I'll put minus 3x first. So we're going to have y equals minus 3x and then plus 2. So clearly the gradient is just the value from the x. In this case, minus 3. That's it. So m equals minus 3. Now for the second part, it says, does the point with coordinates 100 and minus 302 lie on this line? Give a reason for your answer. Well, to show that a certain coordinate lies on a certain line, you must be able to plot this x value and it should output the same y value. In other words, if you plot 100 here, you should get minus 3/2 here. That's if it lies on a line. But let's test that for a second, yeah? Let's say, okay, so let y equal 2 minus 3 times 100. Well, if you put this quickly in the calculator, you should get a result of minus 298. So no, it doesn't equal minus 302. So therefore, the answer is no, does not lie on line L. And that's it, like not much to it. All right, number 2. So find the lowest common multiple of 28 and 105. Okay, so for these kind of questions, we always start with one of these pair of numbers, which is 28. And the objective is to keep breaking it down into prime factors, yeah? And the best way to do this is to use the factor tree. So looking at 28, what I could just infer from this is this can be divisible by 2. And we know that 2 times 14 gives us 28. So guys, keep on reducing this till you get prime numbers, yeah? And every time you get to a prime number, always circle it. So now from 14, we have 2 and 7, and that's it. So here's your prime numbers. Repeat the same for 105. Well, we know this is divisible by 5 because anything ends in a 5 is 5 times table. Divide this by 5, you get 5 and 21. Break 21 down, you get 3 and 7. So, and then these are your prime numbers, 5, 3, and 7. Now, since we've done this part, we need to now figure out what the LCM of these two numbers are. Now, what I personally do is that I always draw a Venn diagram. So let's draw a Venn like this, and I label the first circle 28 and the second one 105. And in the center, I always put the common prime factor in. So looking at all these numbers, you can see 28 has 2, 2, and 7. 105 has 3, 5, and 7. Now looking at both, they both have a common value of 7. So put 7 there and then cross these out. And then we just put the rest in the other cells. Well, 28 also has 2 sets of 2, so 2 times 2, we can just write 2 squared. And 105 has a 3 and a 5. Now, to calculate the LCM, it's literally the product of every number you see inside. So we say, all right, therefore, the LCM is going to be 2 squared times 7 times 3 times 5. And that's it, guys. This is your answer. And just in case it doesn't say leave it in this form, I will just put this in the calculator and you should get 420. And that's it. That's 2 done. All right, guys. Number 3. The diagram shows a shape. The shape has area 129 centimeters squared. Work out the value of x. Okay, when you get shapes like this, my advice is to always try and split them up. So what I would do is just draw a dotted line somewhere around here. Then I'll just try and work out the area of each block. Now look at the shape. We can see that the first rectangle is just an area of 9 times 12, which is 108. And we know that the small rectangle has a width of x and also a height here of, well, if you know the whole height from here to here is 9 and it's cut by 6, this means that its remainder must be 3. Okay, and we know that means the area here is 3 times x, which is 3x. Now at this stage, all you want to do is realize that the sum of these two must add up to make 129. So we say, okay, 108 plus 3x must equal 129. And then just doing the maths, let's subtract 108 across. So we're left with 3x equals 21. Dividing by 3, therefore x must be 7. And that's it, guys. Okay, number 4. So the table shows information about the weights in kilograms of 40 babies. Okay, so here's your weights. So this table trying to tell us that for babies that weigh between 2 and 3 kg, there's 12 of them. Whereas on the last class, there's only one baby between 6 and 7 kg. Okay, cool. Now, write down the modal class. All right, so when you see the word modal, this means the mode or the class that has the highest frequency. Well, we can see that the class with the 16 is this group here. So we just write that entire thing in. So the answer is just basically W between 3 and 4. And that's it. All right, B. Work out an estimate for the mean weight of the 40 babies. Okay, so in order to work out the mean weight, we need two things. The first thing we need is the total weight of all these babies. And because you've got a frequency table, the best way to get total weight is to find the midpoint first and multiply against the frequency, then add them up. Okay, so let's write here. So first things first, we need a midpoint column, and we need to just find the midpoint of all the weight values. Well, the best way to find the midpoint is just simply add them up and divide them by 2. Or actually, this is quite straightforward. Between 2 and 3 is just 2.5. And the next one should be 3.5, 4.5, 5.5, and 6.5. And then we just multiply these numbers across. So we write a new total here and just call it fx if you want. So we can say 12 times 2.5 plus 16 times 3.5, so on. Once you do the maths here, you should get a total amount of 144, guys, yeah? Once you multiply and then you add them up. And then we say, okay, the mean weight of these 40 babies, well, we know that the total weight for all the babies is 144. We got 40 babies. So divided by 40, you should get a mean weight of about 3.6 kg. Yeah, and that's B done. Okay, part C. So one of the 40 babies is going to be chosen at random. Find the probability that this baby has a weight of more than 5 kg. Okay, more than 5 kg. So let's have a look. So we just have to find a group where it's 5 and bigger. Well, we got 2 columns. We got 5 to 6 and 6, 7. So we got actually 2 plus 1. So we got 3 babies that are bigger than 5 kg. And because we know there are 40 babies, the probability is just 3 out of 40. So yeah, nothing to it. All right, number 5. So 120 children go on an activity holiday. All right, cool. The ratio of the number of girls to the number of boys is 3 to 5. Okay, so straight away we need to realize that the total number of parts here is 8, because 3 plus 5 is 8. Now on Sunday, all of the children either go sailing or go climbing. So it says here that 16 over 25 of the boys go climbing. So this means that the remainder, 9 out of 25 of the boys, so remember this is boys not girls here, go sailing. All right, now twice as many girls go sailing as go climbing. Okay, so that's useful. So for the girls, we can say that this is basically 2 to 1 for the girls. And this is in the order of sailing to climbing. Work out how many children go sailing on Sunday. Okay guys, so there's quite a bit of info here. So what we should do is try and collect and break up the info here. Now, if we go back to the beginning, it says that there was 120 children that go on activity holiday. We know out of this 120, there's a total of 8 parts that represent boys and girls. So straight off the bat, we can say that 8 parts must represent 120 children, right? This means that for only a single part, so 1/8 of it, if we divide 120 by 8, we should get 15 children. So 15 children represents a single part. So therefore, we can see that 3 parts, which represents the number of girls, must be 3 times 15. So 3 times 15 is 45 girls. So that's how many girls there are. Therefore, the 5 parts are for the boys. So 5 times 15 is 75 boys. And yeah, looks like we're almost done. So remember, we're only interested in how many children actually go sailing, yeah? So we know straight from the bat that 9 out of 25 of boys go sailing. So that means since there's 75 boys, 9 out of 25 of 75, so 9 over 25 times 75. If you just quickly put that in your calculator, you should get 27 go sailing, which are boys. As for the girls, well, it says twice as many girls go sailing as go climbing. First things first, how many girls are there again? Well, there are 45 girls. We know that 2 parts go sailing, 1 part go climbing. This means there's a total of 3 parts for girls. So we can say off the bat that 2 out of 3, or 2/3 of girls go sailing. So we can say 2 over 3 of the total number of girls, which is 45, go sailing. And doing this in the calculator, 2 over 3 times 45 should gives us 30. And therefore, the total number of children that go sailing must be 27 plus 30 equals 57. And that's it, guys. That's 5 done. And number 6. Okay, write 7.8 times 10 to the negative 4 as an ordinary number. Oof, alright, this is so good. All this naturally means is that you want 4 zeros behind the 7. Okay, so every time you go negative power, take the unit digit and just put whatever number zeros it tells you. In this case, 4. So it's going to be 4 zeros like that, and then 7, 8. And we always put a decimal place over here. And that's it. That's literally 1 mark for that. And B, work out this whole sum and give your answer in standard form. Again, like you can just literally put this all in your calculator one time. If you got a Casio calculator, put all these digits on the top and then go down and put this on the bottom. When you do that, you should get an answer that looks a bit like this. What is it? 22,500,000. Okay. Now, to write this in standard form, a nice little tip I personally recommend is always underline the first digit. Okay, so let's write that 2. And always write 2 point and write every non-zero digit you have. In this case, it's 25. So you go 2.25 times 10 to the power of, well, to figure out what the positive power is, we just count how many numbers are after the first 2. Well, we got 3 zeros, another 3 digits, and another digit here. So that's 7 digits. And that's it. This is your final answer. Alright, number 7. So part A. Expand and simplify m minus 8 times m plus 5. Okay, so this is just your standard double bracket, yeah? So to expand this carefully, all you got to do is multiply term by term, yeah? So here we do m times m times 5, minus 8 times m, and minus 8 times 5. Okay, so when you do this, and let's have a look, we get m times m, which is m squared, m times plus 5, which is plus 5m, minus 8 times m is minus 8m, and then minus 8 times 5 is just minus 40. Now every time you get to the stage, we always need to simplify the middle 2 terms, yeah? And if you do it carefully, you realize that 5m take away 8m is just minus 3m. So therefore, our final answer after simplifying is just m squared minus 3m minus 40. And that's part A done. Now for part B, they want us to factorize fully 5y plus 20y squared. And what they usually mean when they use the word fully is that there's probably 2 steps involved. So let's have a look. Now to factorize comfortably, the best thing to do is to firstly look at the numbers, then ask ourselves, what times table do they both go into? Well, we got a 5 and a 20, and they both go into the 5s. So let's divide this by 5. So the way we do it, we pull out the 5, divide both terms by 5, and we're left with a y and a plus 4y squared. Now we ask ourselves again, is there any other terms? Well, we can look at the y terms now. They both have a y involved, so we can divide y from both. So pulling out the y, we've got 5y outside. Dividing each term by y, we're left with a 1 and a plus 4y. And that's it, guys. This is done. Alright, part C. Now simplify all of this to the power 0. Well, you don't even need to think. We just have to realize that anything to the power 0 is always 1. Okay, and that's it. D. Solve this equation and show clear algebraic working. Alright, so for these kind of problems, you got a bracket, so always expand the bracket, and you got a fraction, so clear the fraction. Now, looking at the left side, I want us to go ahead and multiply out the bracket, so times in this slot by 3, you should get 6x minus 15, and this is going to equal now the right side, which is 9 minus x over 2. And from here, what we should do next is clear the fraction. And when we say clear the fraction, you should try and get rid of the 2. And the opposite of getting rid of this is by multiplying the whole thing by 2. So that clears automatically. When you do that, this is going to go, and now we're going to get 12x minus 30 equals 9 minus x. And that's it. So the fraction is cleared. Now this is just a case of just moving things into the right place. So to solve for x, all you got to do is move all the x terms to one side and the non-x terms to the right. So what I'm going to do, I'm going to move minus x across, and I'm going to move minus 30 to the right. So this is going to move here, and minus x is going to move there. So doing it carefully, if we add x across, we're going to get 13x. If we plus 30 across, we're going to get 9 plus 30, which is 39. And now to solve for x, all we got to do is separate the 13 from the x. And to do that, we've got to divide both sides by 13. So therefore, you're left with x equals 39 over 13, which is just 3. And that's it, guys. All done. Okay, number 8. So on the grid, enlarge the shaded shape, so this one over here, with scale factor half and center 1, 2. Okay, so what this secretly means is that we need to shrink this by half. Okay, that's what scale factor half means. If it said enlarges by scale factor of 2, this means you got to double it. Now the second point, which is the point 1, 2, this is going to be your center of enlargement. So the point where you're going to be looking to enlarge it from. So let's find 1, 2 for now. So 1, 2 would be 1 and up here 2. So it meets here. So this is kind of like where your eye would be and where you'd be enlarging it from. Alright guys, so what we're going to do now is that we're going to connect the center point here to every single vertex, yeah? So check it out. So what I'll do, I'll connect a straight line here. So for you guys, it's better use a ruler. And then I'll be doing it for at least, well, 2 of this for now. So from here to here. And basically the main idea is that we're trying to see where the halfway point is. And so we kind of have to estimate it in our minds. So once we do this, let me get my pen. Now I'm going to just look at the distances from here. So if we kind of imagine that we start at 1 and it goes up to a vertex of, what's this, 7. So our halfway point is probably over here, okay? So just go across the line so you can kind of imagine where the halfway point is. Usually it's going to be on an actual fixed point. Same thing here. Imagine this point now. So if the halfway point will probably be around here, okay? So again, half the distance from here to here, just like from here to here. Now at this stage, what you want to do, guys, is now connect these two together. Because when you connect these two, you're going to have basically the same shape as this one, but it's now been scaled down by half. So let's have a look. So I'm going to just change this. So connect this point to here. Okay, change the color of my pen, make it red. So yeah, you can kind of see it matches. And then if you look carefully, if we had to just scale this one by half, we got like what, a distance of, how many blocks is this? So 2, 4, 6, 8. So we know that it's going to have a distance of half of 8, which is 4. So again, we add another straight line. So insert straight line from here, and you go 4 across, like somewhere over here. Again, make it red, and so on. And then, well, you get the idea now. So once we do this, we now again repeat the rest of the shape. But at this stage, I guess it's quite easy, because all you're gonna do now is you're gonna go down from here, and then you're gonna go straight across. And that's it, guys. You've effectively scaled this by half. So this is the beauty of it. So when you have like a center of enlargement and you got a fixed point, you can kind of guess or strongly estimate where it's gonna be, and that's it. And we're done. And if you actually carry this on, by the way, just for the sake of completion, guys, yeah, if you carried on to the next vertex, you'll realize that it actually cuts off perfectly here. And again, if we did another one from here, you'll realize that again, this corner here cuts off perfectly here as well. So yeah, it actually works perfectly. And that's it, guys. This is the end of the question. Okay, number 9, guys. So here is a right angle triangle. Now calculate the length of PQ, which is the long hypotenuse side here, and let's call that X since we'll be working at that. And then give your answer correct with 3 significant figures. Alright guys, so I made a few notes here. Every time you got a right angle triangle, we're either going to use one or two methods. Either Pythagoras' theorem, if we're only dealing with lengths and no angles, in this case we will not be using, or we'll be using trigonometry, or more specifically, SOHCAHTOA. Okay? Now use SOHCAHTOA if there's angles involved with your lengths, and it's a right angle triangle. Now to use SOHCAHTOA, and you're actually given this in the formula sheet above, guys, yeah? All you got to do is firstly label your relevant sides. Now looking at this triangle, the only side that we actually care about is the side on the left and the hypotenuse. Well, if you're looking at the side next to it, this is known as the adjacent, yeah? Why? Because the length opposite the angle of interest is the opposite. So this would have been the opposite. In this case, we don't care about because we're not solving it. So all we need is the adjacent and the hypotenuse. And then we ask ourselves, out of the 3 options here, which one involves A and H? Well, we can see that K involves them. And well, the C part stands for the cos. For the other 2 guys, the S is the sine and the T is the tan. And for K, we can write that as an equation, which can be represented as cos of the angle, so cos 63 equals A, which is the adjacent, in this case 24.3, over the hypotenuse X. And that's it, guys. Then all you gotta do now is just literally rearrange your equation. And to rearrange it nicely, what I would do is I'll multiply X across and divide cos 63 across. So you're gonna have something like X equals 24.3 over cos 63. Okay, and then when you put this in the calculator, you should get a simple answer of roughly 53.5 centimeters. And that's it. That's this question done. Alright guys, number 10 now. So the shaded region in the diagram is bounded by 3 lines. The equation of one of the lines is given. Okay, cool. So they actually gave us this line over here. So y equals a third x minus 2. That is so helpful. Write down the 3 inequalities that define the shaded region. Okay, so we basically need to change these equal signs to greater or equal, less than equal signs. Now to do this one comfortably, and my personal tip is to firstly forget the inequalities for a second and try and define the lines, yeah? So let's look at this diagonal line starting from over here. So this line going here. Now every time you have straight lines, always think of the usual equation, which is y equals mx plus c. Well, to find m, which is the gradient, we just need to pick 2 points and then pretty much find its gradient. And then to find the y-intercept, c is just where it hits the y-intercept. So in this case, for the y-intercept, it hits at 4. So immediately we can call this line mx plus 4. Now to get m, let's pick 2 random points and calculate its gradient, yeah? So what I would do, I'll just pick, let's say, this one here and this one here. So this is 0, 4, and this one is 2, 2. Now to calculate the gradient is simply the change in the y coordinates over the change in the x coordinates. Well, looking at the change of the y, it's going to be 4 take away 2 over 0 take away 2. Now guys, when you subtract coordinates, always do in the same order. So if you start with the first one, you have to also start with the first one again for the x coordinate. And then working this out, you're going to have 2 over minus 2, which is just minus 1. So the gradient is just minus 1. In that case, our equation is therefore y, so let me write here, y equals minus x plus 4. Or to make it look a bit more fancy, you can plus x across, so it'll be y plus x equals 4. Both is fine. Now at this stage, we need to figure out what kind of inequality to put for each of these things. And, oh yeah, there's also one more line. So you see this vertical line going down. You don't need to worry about a complicated equation. It's just where it hits on the x-axis. Well, carefully, if you look carefully, it hits actually at minus 1. So this line is simply x equals minus 1. Now, let's go ahead and define inequalities, yeah? So to figure this part out, let's start with the y equation here, yeah? So because the shaded region is above the line, and as we look at the y, it seems to be going on the higher end. This means that because it's above, it's going to be greater. So this inequality would be let's write down here, y is greater than equal a third x minus 2. So this is talking about everything above. Yep, above. Now, as for this line over here, the other diagonal line, well, we can kind of see that it's on the left-hand side. So technically, it's actually below, yeah? So if you're looking on the y-axis, it seems to be going down. If you look on the x, it seems to be shifting to the left. So in both cases, they're going down. So our equation here is just y plus x less than or equal 4. Now, if you're wondering why we're using the equal sign, well, it's because they're using a bolded line. When you use a bolded line, it means you include the values. If they use a dotted line, it means it will just be less than, or in this case, greater than for this equation. Now for the third one, and this vertical line going down, this is just going on the right hand side of this equation. So in other words, it's going to be greater or equal than minus 1. So this would be x greater equal minus 1. And yeah, that's it, guys. So make sure you put your 3 inequalities clear and you should get the marks. And that's it. All right, number 11. Ooh, okay, so this is Reba. So Max invests $6,000 in a savings account for 3 years. The account pays compound interest at a rate of 1.5% per year for the first 2 years. The compound interest rate changes for the third year. Okay, so keynote, we can see in the first 2 years, the rate is fixed at 1.5%, but for the third year, it's different. Now, at the end of the 3 years, there is a total of $6,311.16 in the account. Work out the compound interest rate for the third year. Give your answer correct to 1 dp. Okay, cool. So to work this out, we always use the standard OV/NV formula, which is like this. We say that the original value, which is multiplied by some multiplier, 1 plus a rate, for some number of years, should equal the new value. Now, the difference in this equation is the fact that we have different interest rates for different years, especially the third year. So we can now modify this equation as this. So this is now the original value times 1 plus the first year's rate, so let's call this R1, times the second year's rate, R2, times the third year's rate, R3, and it's now going to equal a new value. Well, all we can do now is literally put in everything we know. So we know that the original value was $6,000, so it's going to be 6,000 times 1 plus the first year's rate. Well, 1.5%, guys, if you put that in your calculator, that's basically the same as 0.015. If you got the percentage button, you could actually write directly. So essentially, 1 plus that is just 1.015. Again, the second is the same, 1.015. However, the third year we don't know. Let's just call it 1 plus r, yeah? And it's going to now equal the total of 6,311.16. Okay, so this isn't as bad as it looks, I'm not going to lie. All you got to do is literally rearrange this to make r the subject, and you're done. Now to do this, what I personally recommend is that you could go ahead and smash all of these 3 in the calculator if you want. And whatever you get here, let's just call it answer for now. We're going to now divide this across to the right hand side, yeah? So we're now going to get 1 plus r equals 6,311.16 over your answer, right? And then whatever this is now, you're going to now subtract it by 1 to get r the subject. So r equals all of this minus 1. And when you do that, you should get a value of 0.021, which is actually the same as 2.1%. And that's it, guys. You're literally done. Alright guys, number 12. Alright, so it says that a total of 80 men and women took part in a race. Now a cumulative frequency graph gives information about the times in minutes they took for the race. Okay, so breaking this down, we can see that across the horizontal axis that this is all the minutes they spent. And on the vertical, we got the cumulative frequency for all the adults combined, yeah? So just to understand it clearly, we can say that for the first 10 adults, they spent about 31.5 minutes in a race, so they're quite quick. Whereas if you include every single adult, all 80 of them, then the longest they possibly could have taken was 70 minutes. Okay, so this is probably the slowest of the group, I think, depending on the question, I guess. Now A, use the graph to find an estimate for the interquartile range. Okay, so interquartile range means the difference between the upper quartile, so Q3, minus the lower quartile, Q1. So the upper quartile here, to calculate, well, we know there's 80 people. the first quarter is pretty much means you divide it by 4. So the first quarter of this group. Well, 80 divided by 4 is 20. So we're talking about here. And that's going to be over here. So we can see that the first quarter lies somewhere here, which translates to about 38 minutes. So that's your LQ. As for the upper quartile, that's pretty much the third quartile. Well, 3/4 of 80 is 60, so it's going to be here. And then again, that translates to about somewhere over here, which shoots down to 56. So that's your, what's it called, your upper quartile. So the interquartile range is just the difference between 56 and 38. So 56 minus 38 should give us 18 minutes. And yeah, that's this part done. And for part B, it tells us that 60% of the men took 50 minutes or less for the race, whereas no women took 50 minutes or less. Okay, so just looking at this information, we can see that over here, no women were part of this group, but only men were here. And in fact, 60% of all the men were here. So just looking up at the 50 mark, just to see where it hits around here, which actually counts for 42 people of that population. And remember, all of these guys are men, so actually 60% of all men represent 42. So we can say that 42 men actually accounts to 60% of all the men. So technically, if you want to find 100%, well, you can easily just find 10% first. So dividing that by 6 will give us 7 men. And then to find the whole cohort, which is 100% of the men population, that gives us 70 men. Okay, so let's see what the question actually wants. B, work out an estimate for the number of men who took part in this. Okay, I guess we did it. The answer would be 70 men. Yeah, so actually we actually did the question. The diagram shows a solid cube. Now this cube is placed on a table so that the whole of one face of the cube is in contact with the table. Okay, the cube itself exerts a force of 56 newtons on the table, so that's the downward force going down. So you don't really need to know this specific, but this is the downward force. The pressure on the table due to the cube is 0.40 newtons per centimeter squared. So here they gave us a formula of pressure, which is force over area, and they want us to work out the volume of the cube. So first things first, we know that the pressure itself is 0.14. The force is 56, so that's these two covered. So we can kind of work out the area, and well, the area is basically base times height. In other words, W times W, which is W squared. So I can write that down here. And the volume itself is just base times height times the width. So W times W times W, which is W cubed. Now, essentially, we just need to find what W is. So using the pressure formula and just substituting the values in, we're going to have 0.14 on the left equals a force of 56 over an area of W squared. Now, to solve this one, just rearrange and make W squared a subject. All I would do is times W squared across and divide 0.14. So you get W squared equals 56 by 0.14. Now, put this in a calculator and then square root the answer. You should get a W value of 20. And therefore, to get the volume, just cube this result. So the volume is W cubed, which is 20 cubed, and that is 8,000 centimeters cubed. And that's it, guys. That's 13 done. Okay, question 14. So the diagram shows a parallelogram EFGH. All right. Now we got a couple lengths and an angle which is already defined. A, work out the area of this shape. Okay, cool. So to work on area of parallelogram, it's a bit tricky. So what I personally recommend is always try and break down shapes like these into triangles, yeah? So my advice is to start at E and just slice it across till you get to G. And then you'll realize that you're going to get two equally sized triangles. Okay, and then when you have two equally sized triangles, you can literally just find the area of this triangle and then double it to get the area of the parallelogram. So two triangles, add them up, and you got it. Now, to find the area of a triangle, it's just one straight up formula, and I think they give this to you as well. It's basically half AB sine C. And well, to use this formula, you always need an angle between two lengths. And well, we got it. So A and B are your lengths and C is your angle. So this means that the answer is now half times 9.3. and then you got, what is it, 14.7, and then sine 106. So put this in your calculator and then double your answer because you want to find both of these, yeah? So basically all of this times 2, and doing that you should get an answer of approximately 131 centimeters squared, and that's it. So going to B now, it says work out the length of the diagonal EG on the parallelogram. So EG is the one we just found, so let's just call this X, yeah? Give your answer correct to 3 sig figs. So same things applies, yeah? When you got 3 lengths and an angle, always use the cosine rule, yeah? So the cosine rule itself, I believe, is given in the formula sheet. If not, the general formula is like this. It's always a squared equals b squared plus c squared minus 2bc cos a. Now the most important element here is the angle, yeah, a, and this is represented by this a here, and this means that the little a, which is its opposite, is this length. So that means x is little a and capital A is 106, which means b and c are the rest, 9.3 and 14.7. so all you need to do now is just sub everything back in, guys. So we should have x squared equals 9.3 squared plus 14.7 squared minus 2bc times cos 106. Yeah, so all of this is connected, yeah? And then when you put all of this in, remember you're going to get a result for x squared, so then you'll need to square root answer. So x equals square root of whatever that answer was, and you should get a length of about 19.4 centimeters. Yeah, and that's it. 14 is done. Alright, number 15. So the diagram shows a cuboid of volume V, and it looks like we got lengths given in terms of x's, okay? So this looks like a purely algebraic question. Now A tells us to show that the volume can be represented by this cubic equation. Oof. Alright, so it looks like it's going to take a while. Now what it's trying to tell us is that firstly, let's find the expression for volume. Well, we can know that the volume is just the product of these 3 lengths, yeah? So let's go ahead and multiply all 3 terms, yeah? So we're going to have 2x plus 5 times x plus 1 times 3 minus x. Now there's a number of ways you could do this, and my personal way is to always focus on the last 2 brackets, expand it, then deal with the first. So let's go ahead and expand these 2, yeah? So we're going to go ahead and leave 2x plus 5 alone. So to expand this side, let's multiply it term by term, yeah? So we can say x times 3, x times minus x, 1 times 3, and 1 times minus x, okay? So when we do that, we're going to have a 3x, x times x is minus x squared, plus 3, and then 1 times minus x is minus x. And then go ahead and simplify this, yeah? So we're going to now have 2x plus 5 multiplied by all of this, but tidying this up first and do it in terms of power order, guys, yeah? So always start with the x squared. So we're going to have minus x squared first, 3x, take away x is plus 2x, and we got plus 3. Okay, so step 2 now. Now what you're going to do here is that you're going to now multiply this linear term with every single term in the second bracket. So what I'm trying to say is that we're trying to do 2x times that, 2x times 2x, and 2x times 3. And then after that, we'll do 5 times this, 5 times that, and 5 times that one. So there's 6 things to multiply. And when you multiply it, we're going to lay it out in power order, yeah? So check it out. So you got 2x times minus x squared. That's going to give us minus 2x cubed. 2x times that is plus 4x squared. Then we're going to get plus 6x. So keep in mind of the power orders, yeah? Next, we're going to move on to the 5 now. So 5 times minus x squared would be minus 5x squared. So just line it up. 5 times that is plus 10x. And 5 times 3 is plus 15. Now finally, all you want to do is just put a line and then collect the terms. So in order, you got minus 2x cubed. That goes first. 4x squared minus 5x squared is minus 1x squared. 6x and 10x is 16x and plus 15. And then checking with our result, is it the same? Yes, it is. Except they did it backwards. It shouldn't be a problem, but just for the sake of it, just also write it like that, yeah? So I would say volume equals this, and then copy this out in that order, and you're done. Okay, so looking at part B, it tells us now that there is a value of x for which the volume of the cuboid is a maximum. Okay, so this is talking about differentiation. Let's have a look and I'll try and explain along the way. So what we want to do is differentiate this equation. So I'm going to continue from here, yeah? So let's say now we want to find dv over dx. So differentiate volume with respect to x. To differentiate, guys, all you got to do is drop the power down. So it'll be 3 times minus 2, which is minus 6. And subtract the power by 1, so you get 2. Repeat the process, you get minus 2x to the power 1. If you just got x left, that vanishes, so you get plus 16. If you get a constant, there's no x, so that's 0. So this would be it. Okay, at this stage, now we need to find a certain value of x here. And in order to do it, we need to firstly equate this to 0. Why? It's because when you're finding maximums or minimums or turning points or stationary points, what they're talking about is that you have loads of curves like this, and a maximum would be the highest point on a certain curve, whereas the lowest point would be a minimum. These are also known as turning points, guys, yeah? But in this particular case, they want us to find this particular point, yeah? This coordinate, absolute highest value the y could be for certain x, okay? To do that, you can see that the gradient here is flat, so we got a flat gradient. This means dv over dx must be 0. So when you see the word turning point, maximum, minimum, stationary point, differentiate and set it to 0. So let's do that, yeah? So let this equal 0. We're now going to have minus 6x squared minus 2x plus 16 equals to 0. And then this is just your a straight up normal quadratic equation. So what I would do is I'll use a quadratic formula. So we can say, okay, let x equal minus b plus minus the square root of b squared minus 4ac over 2a. We're therefore going to have plus 2 plus minus the square root of b squared, which is 4, minus 4 times a, which is minus 6, times c, which was 16. Okay, and all of this over 2 times a, so 2 times minus 6. And when you plug this in, guys, you're going to get two values for x. Well, with a plus result, you're going to get surprisingly a minus answer of minus 1.808 dot dot dot, or you're going to get an x value of, so let me write here, x equals. With a negative result, you're going to get plus 1.47. So now with these values of x, it's going to be only one of them, yeah, because you only got one solution. And well, my personal belief is that it has to be the positive result. Why? It's because you're dealing with a shape and you can only have lengths, real lengths. You can't have negative lengths. And that's it, guys. Okay, 16. So P equals 2A minus C over D. Now, what they have here is they have 3 terms and all of these have been rounded to a certain number of significant figures. Now, for this question, they want us to work out an upper bound for this value P, and we've got to show it working clearly. Now, to work out an upper bound for P or even a lower bound, we need to first figure out what are the bounds for A, C, and D. To do this, I always do like this, guys, yeah? I always write A, C, and D, so always write your variables. Always do inequality signs like this, so less than equal, and also a less than on the right-hand side. And then when you do this, you're going to go ahead and put your lower bound values on the left-hand side and your upper bound on the right. Now, to get an upper bound for each of these values, you just got to think about what the next decimal point would have been for each one. So in this case, you're looking at the second decimal point, the first and the second. Well, the only way you can round a certain value down to this value if there was a 5 at the edge, at the end of it, yeah? So it would have to be 58.45. Likewise, for the next one, it would have to be 20.5. And the next one would have to be 3.65. So that's pretty much your upper bound done. Now, to get a lower bound values, again, it will be something similar, but you got to think about the value less than this one. So to round it up to 58.4, it would have to be 1 unit less than this value here, just before the 5. So it would be a 58.35, okay? Next one would be, let's have a look, 19.5 and then 3.55, okay? So that's the key idea. Now to work out the upper bound value for P, so P upper bound, we need to firstly think about what values we need to choose here. And by the way, guys, we can't just pop in any upper bound values for all of these terms because it won't give you the actual highest value. To get the highest, we need to pick the greatest difference between A and C, and the greatest ratio between A and D, or the top and the bottom. To get the greatest difference, we need to have the biggest value for A and the smallest value for C. So it's going to be 2 times A, which is an upper bound, minus C, which is a lower bound, all over the greatest distance. So you want to have the greatest distance over from these two. So you need the lower bound for D. So you have to maximize the top and then minimize the bottom. So that way you're going to have a really big number. So when you guys do this, you're just going to replace AU with this value here, C, the lower value of C with this value here, and the lower value D with this value here. And then when you do that, so let's have a look. So we've got to show it. So it'll be 2 times 58.45 minus the lower bound of C, which is 19.5, over, where is it? Where's my mouse? Over 3.55. And when you guys do this, you should get an answer which rounds to approximately, so to 2 dp guys, yeah, 27.44. And that's it. Okay, number 17. So guys, for this video, this is going to be the last part. Okay, so we got 17a and 17b. Let's do this. Now for part A, they want us to show that the left hand side can be rewritten as the right hand side. Okay, doesn't look so bad. Show each stage of your working. Now to do this, let's go ahead and write 2 of these brackets, because the squared bracket means there's 2 of them. So we've got 6 plus 2 root 12 times 6 plus 2 root 12. Okay, so now we want to go ahead and expand this, guys, yeah? So we're going to do 6 times 6, 6 times these lot, this times that, and 2 root 12 times 2 root 12. Now, 6 times 6 is 36. Now, when you times a whole number with a mixed surd and whole, always times 6 with the whole number 2. So it'll be 12 root 2. So we're going to get plus 12 root 2, 12 root 12, sorry, plus another 12 root 12. And then we've got this term times this term. Again, you times whole of whole, surd of surd. So you're going to get plus 4 root, well, 12 times 12 is 144. And the square root of 144 is, well, 12. So essentially, this is 4 times 12, which is 48. So plus 48. Now, next step. So breaking this down further, we're going to go ahead and collect like terms, guys, yeah? So we're going to do 36 plus 48. That's going to give us 84. 12 root 12 plus 12 root 12 is 24 lots of root 12s. So to collect like terms in terms of surds, guys, always think of these surds as x's, yeah? So it's like saying 12x plus 12x will give us 24x. Now we're almost done. What we need to do now is somehow factorize. And oh yeah, we need to break down root 12 to get root 3. Now thankfully you got a calculator, guys. So I will just put root 12 in. If you put root 12 in, you should get a result of 2 root 3. And well, 2 root 3 times 24 will give us 48 root 3. I mean, technically you could just write 24 root 12 and you get that as well. And again, put 84 here. And then lastly, if you factorize this carefully, I mean, we don't even need to think at this stage. You know you're going to pull out 12. So dividing this by 12, you should get exactly as it is there. So we get 12, and you're going to get 7 here, and you're going to get 4 root 3. And that's it. That's 3 marks bagged. And lastly, for part B, guys, simplify fully this entire algebraic fraction. Now, thankfully, this is not as bad as it looks, because again, you got a calculator, and there's a trick to this. Now, when you got all of this term to a power, what I would do is distribute the power to each term, yeah? So what I'm trying to say is that 27 will get a power of minus 2/3. A to the 12 will get a minus 2/3. Because they're on the same line, you just stick them on like that. So they're multiplying at the stage. And then t to the power 15 would also get it. Now, all of this is just calculator work. So 27 to the power of minus 2/3 is 1/9. Now, for the next part, it's just going to be 12 times minus 2/3. That's going to give us minus 8 as a power. And for the t term, 15 times minus 2/3 is just minus 10. Okay, I mean, this looks like a legit answer, right? Now, I'm guessing they probably want you guys to simplify this answer fully. So probably don't leave a negative form, yeah? So what I would do is, firstly, you got 1/9. 9 goes on the bottom. A to the negative 8, that flips underneath, so it becomes a to the positive 8. T to the negative 10 goes up, it becomes t to the plus 10. So yeah, so negative powers essentially means reciprocal, so bring it down, bring this back up, and 1/9, bring it down. And that's it, guys. This should be your final answer. So there are 16 sweets in a bowl. 4 of the sweets are blackcurrant, 5 of them are lemon, and 7 are oranges. Okay. Now Anna, Ravi, and Sam each take at random 1 sweet from the bowl. Work out the probability that the 5 lemon sweets are still in the bowl. Okay, so it's interesting because in this question there's already 5 lemon sweets that are here, but what they're trying to ask here is the fact that you do not touch the lemon sweets at all. So you want to find combinations or probabilities of other sweets that are not lemon. So one possible combination that you could do, guys, is this. We could take, for instance, so let's say Anna takes blackcurrant and Ravi takes blackcurrant, and also the other guy Sam takes blackcurrant. So this is one option. Or you can decide that they all take oranges, so 3 oranges. And you can notice that we haven't touched lemon yet. Another combination could be this. You could also take maybe a blackcurrant first, and then 2 oranges. Or maybe a blackcurrant and another blackcurrant, and this time an orange. So what you have to do is literally list all the possibilities and then deal with the probabilities later. So another possibility would be, what have we not done? An orange and 2 blackcurrants, and an orange and another blackcurrant. So how many we got? We got 2, 4, 6. And is that it? Is there any other combinations here? You got two blackcurrants in this order. Oh yeah, there's also this one. You could also have a blackcurrant first, an orange, and then a blackcurrant. Or you could have an orange, a blackcurrant, then an orange. And I believe that's it. So you should have 1, 2, 3, 4, 5, 6, 7, 8. 8 different combinations. Now, to actually work this out, we just stick the letter P in front of each of them. And this is literally to find the probability now of getting this particular order. So I'm just going to do one of them, yeah? Or a few of them, and then the rest should be easy. So for instance, find the probability again, BOB, yes? Blackcurrant, orange, and blackcurrant. Well, to get blackcurrant is 4 out of 16, because there's 4 of them, and you've got 16 sweets, times. And now because you're eating the sweet, you now got 1 less sweet, so the next one will be out of 15. Well, to get oranges, there's 7 of them. Now you've got 14 sweets left. And because you already ate 1 blackcurrant, you've got 3 left. So this is one possible answer. For the next one, OBO, it's the same thing. You've got 7 of them out of 16. Times blackcurrant, you've got 4 of them out of 15. Again, out of 14 is the last one. And because you want another orange, you've got 6. So it's that looking at all these kind of values, for instance, look at BBO. You've got pretty much the same kind of order, yeah? So it'll be 4 times 7 times 3 out of this quantity. So wherever this was, like for instance, to get blackcurrant, you have 4 out of 16 times, to get another blackcurrant, you now got 3 left out of 15, and then to get orange, you have 7 out of 14. So you might have a different order of multiplying, but in fact, you're going to have the same result. So this result and this result will be the same, and also this result will be the same because you've got 2 B's and an O. And same for this one here, yeah? So this result here, OBO, will be the same as this one, OOB, and OOB as well, BOO. And then you got the next one at the top, you got BBB. This is kind of similar. So to get this probability, so I'm going to write this answer here. You're going to get 4 out of 16 times, to get a second blackcurrant, will be 3 out of 15. And then to get a third one will be 2 out of 14. So, and then the last one will be OOO. Well, this is just simply going to be, well, to get an orange, you got 7 out of 16. Another orange, 6 out of 15. And then a third orange, you got 5 left out of 14. And that's it, guys. And then finally, to get your final result, you would have to deal this multiplication for each one. And then when you deal with all of them, you're going to add up all your answers. So whatever this is, you're going to add it to this result, and you're going to add it to this result, and so on. Yep, you're going to do for all of them. And then your final probability, when you actually added everything, you should end up with something like 33 out of 112. But that's it, guys. This is literally done. All right, 19. So the diagram shows a cuboid A, B, C, D, E, F, G, H. Okay, so you got a nice cuboid. And you're given some lengths already, which is good. Work out the size of the angle between AH, so this kind of diagonal line which cuts all the way across. So this is kind of like your typical cuboid problem. Between AH and the plane EFGH. So what it's trying to say here, between that line and the plane, as in the ground. Now, when they say something like this, all they naturally mean is that they want to find the angle between AH and then F to H. So that's how it kind of works. Now, give your answer correct to 3 significant figures. Okay, so let's go ahead and just label this angle for a second. Yeah, so I'm going to call this one X. Yeah, so let's label it X. And oh yeah, guys, because you're working with 3D shapes, we need to recognize that this line here is always perpendicular to the ground. Yeah, so this is actually a right angle. Even though it looks kind of weird, it's still a right angle. Now, to work this out, this is actually a SOHCAHTOA problem. But the only thing is, we need to work out 2 lengths. Firstly, this FH length. And well, actually we don't. We already got AF, because AF is just a vertical height, which is 6. So this length is 6. So to work out FH, we could just do 2D Pythagoras. Because looking carefully over here, you got a length here. So this is also right angle, guys, yeah? Because remember, this is just a cuboid. So you can work out this little triangle here. So I'm going to pull it out over here for a second. So with this right angle triangle, we know we got a horizontal length of 9. And you got a little width over here of 5. And then to work out this kind of diagonal, let's just call it, D, yeah? This D here. We can use Pythagoras' theorem. And Pythagoras' theorem tells us that we got the sum of these 2 sides, the square of them must equal D squared. So it's going to be 5 squared plus 9 squared must equal D squared, yeah? And then just putting that in your calculator, guys, when you sum up those 2 sides, you should get 106, which equals D squared. So just to keep it simple, we can say the square root of that is just root 106. You don't actually need to put this in decimal or bother simplifying it. For now, we'll keep it like that. Now, we're almost done. So let's look at the big triangle we're interested in, yeah? So copying out this triangle here, the 6D and this X over here, redrawing it here, we can say now instantly that we got a length of 6, a D length which was root 106, and we're trying to find the angle X. And this is straightforward. This is just a SOHCAHTOA problem. Now to use SOHCAHTOA, all we need to do is literally label the relevant lengths. So we can see that the 6 here, which is opposite angle, is known as the opposite O. And the root 106 is just next to it, so it's called the adjacent A. Then we ask ourselves, okay, out of SOHCAHTOA, which one has O and A? Well, the only thing that has O and A is TOA. And TOA, well, T stands for tan, yeah? Now, to use TOA, it literally means, well, the T means tan of the angle X must equal O over A. And well, we know what O over A is. O is 6 and A is root 106. So we just update it here. So we're going to have tan X equals 6 over root 106. And that's it, guys. Now, all you want to do here is literally just tan inverse this result. And you got X. So to get X, it will be the tan inverse or tan negative 1 of 6 over square root of 106. And you're done. And then when you plug this in the calculator exactly like it is. And guys, make sure your calculator is in degree mode or deg mode, yeah? This means that, well, the angles we're using is in degrees. Your calculator might be recorded in this mode, rad, which is radians. So make sure you switch up. If you're not sure how to do it, send me a message or, you know, just, you can probably Google it and get the answer straight away. So inversing this, guys, you should get 30.2 degrees. All right, number 20. So the curve C has the equation y equals 4 times x minus 1 squared minus a, where a is greater than 4. Now, using the axes below, we got to sketch this curve, and on the sketch, we need to write in terms of a, the coordinates of any points of intersection of C with the x and y axes, and as well as the coordinates of the turning point. All right, so there's quite a few things to do here. Now, let's do part I for a second, yeah? So let's find the coordinates of any points of intersection with the coordinate axes. So what we're trying to say here, we've got to find out where it hits the x and the y axes. Now, every time you hit the x-axis, there's a couple key things. So if you hit this x-axis, this means that the y-coordinate is actually 0 because it hasn't jumped. So we say, all right, when x equals 0, well, just plug in 0 into this equation. You're going to get y equals, and well, if you want, you could just literally plug in 0 here. Put this part in the calculator, so 4 bracket 0 minus 1 close bracket squared. You just end up with a 4. And then you're left with minus a. And because we know a is bigger than 4, what this is trying to tell us is that a could literally be 5 or 6, 7, and so on. So we can imagine that if a is 5, we got 4 take away 5, which is -1, or if a is 6, you get -2, and so on. So it's trying to say that this value is actually negative. And since it's negative, this implies that when x is 0, y is going to hit somewhere over here. Like, we don't know where, but we can just call this one 4 minus a, yeah? Okay, so that's our coordinate. X, when x is 0, y is 4 minus a. Now, we can also do the same thing when y is 0. So let's go find out when it hits the x-axis, yeah? So when y is 0, we're going to have 0 equals, now just copy the rest of the equation, 4 times x minus 1 squared minus a. Okay, so in this case, we just need to solve for x. And because they've already sort of factorized it for us, we can just plus a across and divide by 4. We're going to get a over 4 equals x minus 1 squared. And then next, we can square root both sides. So we're going to have, so I'm just going to go ahead and flip this around here. We're going to have x minus 1 equals the plus minus the square root of a over 4. And then we can just add 1 across. So x equals 1 plus minus. And by the way, guys, when you square root 4, you get a 2, yeah? So you're left with root a over 2. Okay, and this is actually where it's going to be. Now, just to know where this is going to be roughly on the diagram, just think of some numbers for a, yeah? So let's plug in 5. Actually, let's plug in 9, because 9 you can square root, isn't it? So if a equals 9, because we're trying to figure out where it's going to be. So if a equals 9, then we're going to get, let's say, x equals 1 plus minus. So square root of 9 is 3, so 3 over 2. And this is going to be 2.5 or 1 take away 3 over 2, negative 0.5. So it looks to me that there's a greater proportion of x on the right side than is on the left side. Because if you think about 2.5 is probably here and 0.5 would be around here. You know, just for argument's sake, guys, yeah? And then we can kind of sketch this. Now, we need to recognize the shape of this. So if you look at this carefully, this is a quadratic equation. So this means that it's going to be a U shape. So it's going to be something like this. Okay. Oops. Yeah, so like that, yeah? Yeah, so now we just label our points of intersection. Well, this side is going to be 1 plus root a over 2 because it's positive. 1 plus root a over 2. And the left side would be 1 minus root a over 2. Okay, so looks like we're almost there. We're almost there. So that's part 1 done. And now for the coordinates of the turning point, it's literally right over here, guys, yeah? So the general form is that we always look at the bracket first, x minus 1. That means because it's negative, we want to make this part 0, yeah? So that means x needs to be 1. That's how it is, guys, yeah? And when x is 1, what do we get for y? Well, y is going to be 4 times 1 minus 1 squared minus a. Well, we can see here that 1 take away 1 is 0. 4 times 0 is 0. We're just left with minus a. And that's it, guys. Your turning point is at 1 and minus a. And that's going to be, well, over here. Turning point is this part here. That's the corner of 1 and minus a. And that's it, guys. Looks like we're done. Alright, number 21. So the functions f and g are such that fx is a quadratic equation and gx is a linear equation. Okay. Now the function h is such that hx equals fgx for x greater equal to negative 2. Okay. Now express the inverse function in the form of that. Alright. So there's a few things we got to do here. Now for the first bit, it says h equals fgx. Now we need to realize that this is a composite function, and all it really means is that we got to substitute g into f, and that's how the order is, yeah? When they say fg, it means the second into the first. So we have to basically replace all the x terms here with gx entirely. So what I'm trying to say here, we could say that, okay, fgx is literally, well, we copy this equation sort of. Instead of x squared, it's going to be all of these lots squared. So bracket x plus 3 squared, and then we copy the rest. It'll be minus 2. We're going to times it by the gx, so times x plus 3. And this is essentially, well, our hx, yeah? So at this point, we should try and simplify this. So let's go ahead and expand these brackets. Now just remember, x plus 3 squared literally means you're expanding 2 of these brackets, yeah? So I'm going to do this quite fast, because this is just the usual way. if you have to expand this double bracket, you should get x squared plus 6x plus 9. And if you expand the second part, you're going to get minus 2x minus 6. And then tidying this up a bit, collecting like terms, you can have x squared, where you got 6x take away 2x is plus 4x, and then 9 take away 6 is plus 3. Okay, that's almost done. Now here comes the main part, yeah? So you can imagine this was part 1. Now for the second bit, it says express this function, so this is essentially all hx, yeah? In the form of the inverse, so h inverse function. Now to get the inverse function, there's a nice little trick. So because we work in terms of h, we always start like this. We say, all right, let hy, so then replace all these with y, equal y squared plus 4y plus 3. And now we're going to go ahead and make this all equal to x. And that's it. So that's really what you do. You just flip all the letters around and you make it equal to x. So if we look at this carefully, we can see that we got a quadratic equation on the left and just a random x term here. Well, what I would personally do, guys, is that I would try to solve this equation, but not by the quadratic formula, guys, because it doesn't equal to 0. We're going to try and complete the square, okay? And you're going to see why, because it's actually much more efficient. And well, to complete the square, all we got to do is underline the first two terms and then copy out the y bit by writing y plus and then halving the 4, which gives us 2, and then wrap it around in a square. And then next we copy out the plus 3, but this time we're going to now subtract it by the thing we halve, so 2 squared. And all of this, well, it equals x. And well, tidying up this bit, 3 take away 2 squared is minus 1. So I'm going to go ahead and plus this to the other side, yeah? So we now got y plus 2 all squared equals, well, x, and we're going to add 1 across, so plus 1. So now all you want to do here is square root both sides. So you're going to have y plus 2 equals plus minus the square root of x plus 1. And finally, guys, just subtract 2. So you can have y equals minus 2 plus minus the square root of x plus 1. And that's it, guys. And oh yeah, because it says express this in that kind of form, now we just copy again and just write, all right, therefore h minus 1x must equal minus 2 plus minus all of that lot. And then put that over here. And oh yeah, a little side note, guys, yeah, because it tells us that x has to be greater or equal to minus 2, this means that the result can only be one of it, and it's going to be minus 2 plus, it's going to be the positive answer, yeah, because if you subtract it, you'll probably get a smaller answer. So therefore we just say the final solution is just minus 2 plus root x plus 1. And yep, this is it. And here we go, guys, the final question. Let's do this. Okay. So triangle HJK is isosceles. So let's go ahead and try and draw this as we go, yeah? So we've got a triangle HJK. So HJK is isosceles, and that means these two should be the same, and these two angles should also be the same. Okay. Now it tells us the length HJ equals HK and JK equals root 80. So JK should be down here. So put root 80 over here. Now next point. H is the point with coordinates minus 4, 1. So I'm going to do this in red. So we got minus 4, 1 over here. J is the point with coordinate J15. So J here is J15. K is the point with coordinates 6K. So this is 6K. Okay, cool. Now M is the midpoint of JK. So let's say M is round here, yeah? Point M. And the gradient of HM, so HM, where's HM? Oh, okay, so we can imagine some kind of imaginary line, and it has a gradient of 2. Okay, so the M value here, the gradient is 2. Okay, guys, so now we've got everything done. Let's try and solve this. So what I would personally recommend first, guys, is to try and find the coordinates of M in terms of J and K, and then we'll deal with the gradient part second, yeah? So first things first, to find the midpoint of M, we know for sure that to calculate any midpoint, you go first is add up the x coordinate, so like 6 plus j, and then half it. And to get the y coordinate, we have to add up, well, the y's. So 15 plus k, and then we would half it, okay? Now, according to this question, it tells us that the gradient from M to H is 2. So to calculate the gradient of anything, The gradient, which I'm going to call little m, by the way, guys, is the change in y coordinates over the change in x. So let's go ahead and write the change in y, yeah? So the change in y is just basically 15 plus k over 2 minus, well, 1. And the change in x is 6 plus j over 2 take away minus 4. So it'll be minus minus, it'll be plus 4. And apparently all of that is supposed to equal 2. Now, what I would do, guys, is try and simplify this equation as much as we can, yeah? So I'm going to go ahead and multiply this bottom fraction to the right side, yeah? So I'm going to try and clear the big fraction. So multiplying all of this across, we're going to have 15 plus k over 2 minus 1 left. And it's going to now equal 2 times all of these lot. Well, 2 times all of this, the 2's will cancel out, so you're left with plus j. And then 2 times 4 will give us plus 8. Now, what I would personally do next is I'll try and clear the fraction again. So I'm going to go ahead and multiply all of this equation by 2. So that way this 2 would go. Now, timesing it by 2, you're left with 15 plus k. This becomes a minus 2. We're going to get 12 plus 2j plus 16. And then just collect like terms, yeah? So now, collecting like terms on left, you're going to get 13 plus k equals, well, on the right side, 12 plus 16 is 28 plus 2j. Okay, so what I'll do now is that I'll just probably box this equation here, just to keep it safe somewhere, and just call this equation 1. Well, to solve an equation of 2 unknowns, we actually need a second equation, guys. So actually, we still got more work to do. And to do it, let's have a look. So just recapping the information, it tells us that the length jk is root 80. This means that the difference between the two coordinates using the distance formula will give us root 80. That tells us that, okay, to get root 80, it's going to be root 80 squared equals difference between two coordinates. Let's say difference between the y, so k take away 15 squared plus j take away 6 squared. And well, just look at this equation, root 80 squared is just 80. Now guys, I wouldn't recommend expand this, and there's a reason why. Because if you do it, you're going to have two quadratic equations and it's going to look kind of messy. What I would recommend instead is make, let's say, k the subject here, and substitute that into this equation and then expand it. And that way you're going to have an equation in terms of j only. So let's just copy this down here for a second because it's quite a big question. So it's going to be k minus 15 squared plus j minus 6 squared equals 80. And now from the equation above, I'm going to make k the subject here. So from here, I'm going to subtract 13 across. So we're going to have k equals, what's that? 28 take away 13 is 15 plus 2j. Okay, so let's put that in over there for k minus 15, yeah? So substitute this into that equation there. We're going to have 15 minus 2j and then minus 15 squared plus j minus 6 squared equals 80. And then tidying this up a bit, well, 15 take away 15 is nothing. And then you're left with minus 2j all squared, which is just simply 4j squared. And then expanding the j minus 6, remember this is 2 brackets multiplied. And if you do it fast, you're going to get j squared minus 12j plus 36 equals, equals 80. All right, almost done. Let's go ahead and collect like term, guys, and tidy this up. So 4j squared and j squared gives us 5j squared minus 12j. And then you got, what's that? 36 take away 80, which is minus 44. All right, almost done. Now, yeah, so this is pretty much it. So now we can just solve this using the quadratic formula. So we can say, all right, let j equal minus b plus minus square root of b squared minus 4ac over 2a. And from here, you're going to plug in the values of a, b, and c. And just a quick recap, guys, the values a, b, c are just the values in front of the j squared, the j, and the constant. So this is a, this is b, and this is c. So we've got a is 5, b is minus 12, and c is minus 44. And if you substitute this in carefully inside here, you're going to get an answer of j equals minus 2 or j equals 6. Okay, so now which one is right? And if we look back in the question, it tells us j is less than 0. So this means that j can only be minus 2. So this one is wrong. So looking at all equations that have j and k involved, I'll just pick the easiest one, guys. And I think the easiest one is actually this one because k is nicely lined up when you plug in j. So using j equals minus 2, so plugging this in, guys, you're going to get k equals 15 plus 2 times minus 2. And if you put this in carefully, you should get a k value of 11. And that's it, guys. This is done. So